Okay, so the last video we found slope, right, which is important to know how to do that. What's equally as important is understanding what slope is telling you. Slope is very, very important. It tells us what's called the rate of change of the function. Slope tells us how fast or slow, if it's a big number it's fast, if it's a small number it's slow. A function is increasing if it's positive, decreasing if it's negative, per change in x. Right? So it tells me how fast some value is changing as I increase, right? As I move down. Think about it graphically. It tells me how steep the line is. The bigger the number, the steeper the line, right? Either it's moving up really fast if it's a big positive number, or moving down really slow if it's a small negative number. All right. So again, it tells me how steep the line is. Bigger the number, the faster the increase, the faster the decrease. The smaller the number, the slower the increase, the slower the decrease. All right, so slope is a rate of change. It determines how much the function changes, the output changes, whatever the output represents. People, items, things, dollars. Per 1 unit, it's always per 1 unit increase in whatever the input was. Per year, per item produced, per whatever x is. Alright, so again, that's what it is. It can also be held constant. Remember, keep in mind the zero case means there's no increase and no decrease. It's held constant, right? It's the constant function. Alright, so examples. So these are just some generic examples. So the first one here, I've got f of x equals 2x. So remember, 2 is my slope. And so first of all, it's positive. So it's telling me f of x is increasing. And then I know exactly how much it's increasing by 2 units per change in 1 unit of x, whatever x represents. You can read that, so hopefully you can. Alright, the second one. My function f of x equals negative 0.34x plus 3. What is slope telling you about the function? So slope is negative 0.034, not 0.34, 34. And so it's negative, and so we know f of x is decreasing, which that takes care of the negative part. Right? That's what the negative is telling me, direction. Right? I already indicated my direction. It's decreasing by a smaller amount. Right? This will be a slow decrease by 0.34. You don't put a negative on that because I've already taken care of the negative here. We did decrease, kind of like a double negative. Decreasing by negative, which would actually mean positive, right? It'd be decreasing in the opposite direction. So you don't put a negative here. Decreasing by 0.34 units per change in x, whatever x is. Alright, this is again a special case. What is slope in this case? Well, this is a constant function, which means it's my horizontal line, right? Y equals 6, right? Function value equals 6, so that means my slope is 0. Right? Zero slopes are important. They play a big role if you go into calculus. It's all about the zero slope. It's not all about it, but a big chunk of it is about the zero slope. Alright, so what does the zero slope tell you? It tells me f of x is constant, meaning it's not increasing or decreasing as x increases. Alright, it's being held the same. I get the same y value out no matter what x value I move to. Alright, neither increasing, so it's constant, neither increasing nor decreasing. Alright, so a couple application examples. Because again, this will be where you interpret it with units. Units are very, very important when we're looking at an application. And so when you're dealing with rates of change, it's always the change in my function. How much is my function increasing, decreasing, per 1 unit change in my x, my input values. And so this first example, I kind of spell it out for you. So we've got a car is initially located 300 miles north of the Texas border. That's where we start. It's traveling north at 60 miles per hour, represented by the function. Again, 60 miles per hour meaning how far. So in 1 hour, it travels another 60 miles. So it would be 1 hour, it would travel 90 miles from its start. north of the Texas border. Sorry, north of the Texas border. And so on. In 2 hours, it would be 60 times 2, which would be 120, plus 3, so it would be 150 miles from the Texas border. Right? And so the slope is 60, right? Slope is 60. Every 1 unit it changes, moving up by 60. 1 unit change, it's moving 60 miles in 1 hour, right? That's what the unit change is. It's moving, as I go over an hour, I'm going to go 60 more miles down the road. And so we interpret that by miles per hour. The units kind of give it away. All right, so the distance from the Texas border, the distance the car is, as I should say, the distance the car is moving away from the Texas border is increasing, because it's positive, by 60 miles, right? It's changing, it's moving 60 miles further away from the border per 1 hour, right? Every miles per hour. Every hour, the car gets 60 miles away further from the border. And that's what the slope is telling me. I'm increasing my distance by 60 miles every hour. Alright, let's look at a couple more applications. Alright, so this is a cost application. So I've got the cost in dollars of purchasing X gallons of paint. So there's a couple parts to this. This first one's just an evaluation, and then we'll get to the slope. Alright, so this is a very simple function. The cost function is just 29 times X. Alright, so A is just asking you to find C of 5 and then interpret. So that means I'm going to take 29 times 5, which comes out to be 145. Right, now, it did ask you to interpret. Explain applications. The explanation of what your number represents something, right? Number has meaning in applications. And so that meaning's significant. So when you write your answer, don't write 145. Tell me what the 145 means. Right? This one, in case, it also needs to tell me what the 5 represents. So if the 5 represents the gallons of paint they purchase, 5 gallons of paint it will cost them dollar sign, because it's in dollars, $145. Alright, again, bear with my handwriting on this tablet. I think it gets exponentially worse the more I write on it. Alright, so if you can't read that, what it means is when they purchase 5 gallons, right, that's what the 5 represents, and that's important, because if it was a different number, I'd get a different answer. So when they purchase 5 gallons of paint, it's going to cost them $145 total. Alright, part B, the slope part. Well, the slope is the number in front of the x value, which in this case is 29. And so the slope, remember, slope is the change in my function, which in this case is cost, over the change in x. And so that's what we're talking about. What's the change? Well, the cost increases, this is positive, by, so the cost is in dollars, $29, right, that's the units, $29 per gallon of paint, right, that's the x value, right, so it's the change in the cost per the change in the x. The cost is dollars, that's a unit on it. The x is gallons, right? So it costs you $29 per gallon of paint. That's what the cost function, that's what the slope is telling you. And it should make sense, right? Every time I purchase a new gallon, so if I purchase 1 gallon, it's 29. I purchase 2 gallons, it's 29 times 2, right? I purchased 5 gallons, it was 29 times 5. So every gallon cost me $29. The last application example. Right? The mean age of the U.S. population, mean age, remember, means the middle. Right? It's not the average, it's different. Average is different. This would be the middle. So it means half the population is above this age. So if we have 300 million people, 150 million people are above this age, 150 million people are below this age, right? It's the middle value of the U.S. age population. It's what's in the middle. Over the years, so they collected the data between the years 1970 and 2010. It's approximated by that fun-looking formula. It is a line. It's just an ugly line. Right? It gives the median age in years old, right? So it's the middle age of Americans. Not the average, right? It's the age in the middle. Alright, so part A is just asking you to find that function at 2000 and interpret it, and then the slope. So A is first asking you to find. So the t value is 2000, which is my year. So A of 2000, I take my negative 0.243 times my 2000, minus, not plus, 450.8, which again, I'm just going to round a couple decimal places, or 35.2. Alright, so what that means, in the year 2000, right, because that's the year we're looking at, the median age of the U.S. population was about 35.2 years old. Alright, that's the age. The year's the old. So remember, that's in the middle. It means half the population has an age bigger than that, and half the population has an age smaller than that. That's the middle of the population. Alright, remember that's what median means. Alright, I'm going to race to do my second part. Alright, so part B. Slope, and what does it tell me? Alright, so the slope in this case is that ugly number. Alright, so slope is 0.243, and then what does it tell you? Alright, it tells me how much the mean age of the U.S. population is changing per year. Right, because this is the change in my function, that's the change in y, which is the function a of t, over the change in x, which is the t, the year part. And so that kind of helps you out with the units. Right? It's the change in my function, which is the mean population age, per the change in the year, right, between 1970 and 2010. And so what this means is the median age of the U.S. population is increasing by 0.243 years older per year between 1970 to 2010. Alright, so it means the middle age is increasing, which is good. That means more people are getting older, right, because it's moving up. Alright, we'll stop there. We'll pick up x and y intercepts in the next video. Alright, so interpreting slope, very, very important.